Article 3. The role of large language models, LLMs, in the future transformation of artificial intelligence. Introduction. The emergence of large language models, LLMs, in the past decade represents one of the most fundamental transformations in the history of artificial intelligence, one that has not only reshaped human-machine interaction, but also redefined data science, knowledge production, digital industries, and decision-making structures. These models have evolved beyond the status of a novel technology and today function as the cognitive backbone of numerous AI-driven systems. Understanding the role of LLMs in the future is essentially understanding the trajectory of AI's global evolution. 1. Cognitive architecture of LLMs, a leap from processing to reasoning. LLMs are built on the transformer architecture, enabling them to learn not only words, but also semantic relationships, logical structures, and conceptual patterns. The key difference between LLMs and earlier AI systems lies in this ability to extract meaning. LLMs can analyze complex relationships between concepts, perform multi-step reasoning, anticipate outcomes and implications, transfer knowledge across different domains. This elevates LLMs from statistical language models to quasi-cognitive systems with human-like reasoning capabilities. 2. Multimodality, entering the era of combined perception. Modern LLMs are no longer limited to text. They can simultaneously process images, video, audio, maps, tabular data, and sensory signals. This multimodality allows them to analyze medical images and generate scientific explanations, plan robotic movement, interpret and summarize videos, analyze financial datasets with linguistic reasoning. This evolution positions LLMs as the emerging central engine of future general intelligence. 3. Accelerating the innovation cycle. One of the most significant impacts of LLMs is time compression. Processes that previously required weeks can now be completed in minutes. Examples include software development by a single person instead of a full team product, design from concept to prototype in a single day, analysis of hundreds of scientific papers and generation of hypotheses within hours, production of content, legal documents, marketing material, and reports overnight. This marks a global productivity revolution fueled by cognitive automation. 4. LLMs and the rise of the cognitive economy. The world is transitioning toward an economy in which knowledge, reasoning, and analytical capability are the primary assets. By automating repetitive processes, LLMs reshape workforce structures and redefine the value of human skills. Manual and procedural tasks decrease. Creative, analytical, and design-oriented tasks increase. New roles emerge, built on collaboration between humans and AI organizations. Employing LLMs have reported a 3 to 5x improvement in product development, decision-making, and data analysis speed. 5. LLMs as scientific partners, a research revolution. In scientific research, LLMs act as a 24/7 cognitive assistant. They can identify contradictions across research papers, generate analytical summaries, propose experimental methodologies, discover hidden trends and patterns in datasets. It is predicted that within the next decade, over 40% of global research projects will be conducted with direct participation of autonomous LLM-based agents. 6. Major risks and challenges. Despite their benefits, LLMs bring substantial challenges: extremely high energy consumption bias in data and decision-making, risk of misinformation and fabricated content, security vulnerabilities, and potential misuse. Unresolved copyright and content ownership issues. Addressing these challenges requires a combination of regulation plus ethical design, plus transparent datasets, plus international collaboration. 7. The future of LLMs, from tools to cognitive collaborators. LLMs are evolving toward full integration with human life. They are not designed to replace humans, but to augment human cognitive abilities. In the near future, every individual will have a personal AI agent. Robotics will achieve higher autonomy. Education, medicine, economics, and the arts will undergo deep transformation. Humans and AI will jointly generate new knowledge. LLMs are shaping a new generation of humans, individuals with enhanced cognitive capacity and unprecedented learning speed. Conclusion. Large language models are not merely advanced tools. They are launch platforms into a new era of intelligence and creativity. They elevate analysis, reasoning, decision-making, and knowledge production from a software capability to a foundational element of the digital civilization. The future of AI is a future in which humans and machines operate not as competitors, but as intellectual partners, co-creating the next stage of human progress. Professional Academic English, non-repetitive. 1. LLMs and the emerging shift in global digital power. One of the most significant yet under-examined consequences of LLMs is their impact on the global distribution of technological power. Nations with advanced compute infrastructure, access to high-quality data sets, and a skilled technical workforce are adopting these systems faster, widening the gap in what can be called national cognitive capability. In the near future, countries will be differentiated not by traditional indicators such as natural resources or industrial capacity, but by their sovereign AI infrastructure, data independence, and the maturity of their domestic language models. This evolution introduces the field of AI geopolitics, a domain where LLMs play the same strategic role that nuclear technology played in the 20th century. 2. New categories of jobs created by LLM technologies. Despite concerns about workforce displacement, LLMs are catalyzing the creation of entirely new job categories, roles that simply did not exist before. A few emerging examples include AI behavior architect, designing interaction patterns for autonomous agents; AI risk and ethics engineer, human-machine; multimodal interaction designer, data refinement and quality supervisor, cognitive systems architect. These roles reflect a transition to a labor market where the most valuable skills are hybrid human-AI competencies, not purely human or purely automated tasks. 3. LLMs in the future of surgical, industrial, and rescue robotics. Until recently, surgical or rescue robots operated on rigid, predefined instructions. Multimodal LLMs now enable robots to interpret environments, conceptually evaluate unfamiliar situations, make autonomous decisions, correct their own errors in real time. This represents a shift from mechanical automation to cognitive autonomy. In next-generation hospitals, LLM-powered surgical robots will be able to adapt to unexpected conditions, modify procedural steps, and generate real-time analytical reports, all without interrupting the operation. 4. LLMs as the collective memory of future civilizations. Another emerging dimension of LLMs is their transformation into a form of collective cognitive archive. These models can compress and organize scientific history, rediscover forgotten theoretical patterns, convert raw information into applied knowledge, analyze future scenarios with high-level abstraction. In this sense, LLMs are evolving into what could be described as the intelligent library of humanity. A system that does not merely store information but comprehends it, restructures it, and delivers it back to humans in actionable form. Large language models are not merely advanced tools. They are launch platforms into a new era of intelligence and creativity. They elevate analysis, reasoning, decision-making, and knowledge production from a software capability to a foundational element of the digital civilization. The future of AI is a future in which humans and machines operate not as competitors, but as intellectual partners, co-creating the next stage of human progress.